This week, developers saw the same model score tell two different stories. New measurements and OpenAI guidance say performance depends on the harness, memory design, and API settings as much as on model weights. How you store memory and run agents changes cost, latency, and correctness. Two threads drove the headlines. One compared Mem0 and RE-Call memory designs. Mem0 scored 0.567 on Beam temporal reasoning. RE-Call scored 0.408. RE-Call has zero marginal cost per memory and keeps data local. Separately, OpenAI says retained reasoning and compaction raised GPT 5.6 SAL from 13.3% to 38.3% on ArcAGI 3 and cut output tokens by about 6 times. Concrete updates to note. RE-Call is MIT and runnable locally. On Beam, a distilling baseline fabricated answers on about 46% of some abstention probes. OpenAI recommends disclosing harness, budget tools, and memory behavior. OpenAI documented large ArcAGI 3 changes from compaction and retained reasoning. How these memory choices differ at a technical level. Mem0 distills each write with an LLM into a short memory like Sprint 1 deadline, February 15, 2024. That helps temporal and multi-hop reasoning. RE-Call stores raw turns and retrieves later. Measured trade-offs include accuracy, cost, and latency. One benchmark quoted a per-memory cost of $7.29 for distillation. RE-Call ingests about 4.3 times faster and keeps data local. These are practical differences for product and platform teams. Distillation helps temporal multi-hop reasoning. Non-LLM write paths keep marginal cost at zero and preserve local data. But distillation can produce confident fabrications. On Beam, a distilling baseline fabricated numbers about 46% of the time on some abstention probes. Choose the architecture that matches your constraints. OpenAI's guidance ties this together. Benchmarks are measurements under a specific harness and budget. On ARC-AGI 3, retained reasoning and compaction moved GPT 5.6 SOL from 13.3% to 38.3% on the public set. It also reduced output tokens by about 6 times. Publish the harness, budget, tools, and memory behavior with any score. Multi-agent pipelines pass natural language state between agents. Each subagent may apply its own refusal or safety rules. Conflicts create silent failures. The system completes but gives the wrong outcome. Mitigations include mapping agent boundaries, logging refusals, and defining trust levels. Immediate actions you can take. Verify AI crawlers by reverse DNS with forward confirmation or by published CIDR JWKS files. Run paired harness tests with your retained reasoning, compaction, and re-rankers. Consider RE-Call or similar local memory designs when cost or data locality is critical. Benchmarks can mislead when unanswerable questions are adversarially constructed. On an adversarial split, top 1 cosine AUC was 0.753. On an ordinary held-out set, plain cosine reached AUC 0.780. Abstention depends on how the unanswerable set is built. 3 takeaways. 1. Treat a model score as a measurement under a harness and document it. 2. Choose memory architecture by accuracy, cost, and data locality needs. 3. Treat agent boundaries as interfaces, document trust, and test for silent failures. All sources are in the description, so you can recompute these checks. You'll find the full list of sources in the description. They include the RE-Call and Beam analyses, OpenAI guidance, and ArcAGI 3 write-up, a crawler verification registry, multi-agent notes, developer reflections, and practical tool posts. Check the links to reproduce the experiments and read the code.